These are your 3-5 notes on arithmetic sequences. This leads us into some linear patterns. So let's just get started. We're going to learn how to recognize if it is an arithmetic sequence or not. And then we're going to be able to find terms of an arithmetic sequence afterwards. So first of all, the definition of an arithmetic sequence is just a numeric pattern that increases or decreases at a constant rate of change. So between the numbers listed, they're either being added by a certain number or subtracted a certain number. And we usually say that's just adding a negative number. The numbers in the sequence are called terms. And then that number that you're adding or subtracting each time is called the common difference. So in a pattern like 5, 10, 15, 20, we know that the common difference is positive 5. So my common difference is 5. How you can find D is take a term and subtract the previous term. So this one was pretty easy to see, but if they're not as easy, term minus previous to get that common difference D. So looking at these two examples here, I'm wondering if they are arithmetic sequences. So I will do just exactly what I said I would do, a little bit difficult here. So I'm going to start with negative 9. I'm going to start with a term and subtract the previous term. So negative 9 minus negative 11 tells me that we added 2. Negative 11, take away negative 13, we added 2. And the 15 and 13, I can see that we added 2. So I know the sequence starts at negative 15, goes to negative 13, negative 11, negative 9, but I started backwards. You can do it either way, but you have to start with the second number and subtract the first number to figure out the common difference. So because all of them are the same, yes, this is an arithmetic sequence, and my D value is positive 2. When I look at these fractions, I can do the same thing. I can subtract 5/8 from 7/8. Or I'm sorry, take 5/8 minus 7/8 is going to tell me that my common difference between these two is a negative 2/8. I went down 2/8. Between 5/8 and 1/8, when I subtract them, I'm going down 4/8, which is not consistent. So at this point, I can just say not an arithmetic sequence. And I don't have to say a D value because there isn't a common difference. So if it's not the same within all of them, you can stop looking and just say, no, not an arithmetic sequence. In number 3 here, it's telling me to find the next 3 terms of the sequence. So they're telling me it is an arithmetic sequence. And they want me to find the next 3 terms. So instead of dot, 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 we should have a line, and a line to continue the sequence. So I got to figure out my D value. So I'm going to see what's happening here. I can tell that the numbers are getting smaller, even though they're larger, but they're negative, so it's getting smaller. So my D value is negative. And if I just subtract these two, negative 11, take away negative 8, it tells me my D value is negative 3. So I'm subtracting 3, subtracting 3, subtracting 3. So if I subtract 3 again, I get negative 20. Subtract 3 again, negative 23, and one more time, negative 26. So these are the next 3 terms of that arithmetic sequence, keeping with the pattern of subtracting 3 each time. I'm going to save this table for when we're in class. I think it's a good thing to reference while we're in class. But now we're going to talk about using a sequence. Maybe I wanted to find the 100th term, and I didn't want to list all 100 terms to do that. So you can actually find any term in a sequence once you establish the sequence. So you need to know how many terms are in the sequence, you need to know the first term, and you need to know the common difference. So every term of an arithmetic sequence can be expressed in terms of the first and the common difference. Now, when we do this, I can just fill in this part of the table. My first term we call a sub 1. My second term we list as a sub 2. My third term is a sub 3. My fourth term would be a sub 4. And then we can just continue and say, it doesn't matter what term we're talking about, 5th, 6th, 7th, 100th, 200th, millionth term, we call that the nth term. So that's the ending of all of these. So a sub n is wherever you want to end. It can change. Do I want the 5th term? Do I want the 100th term? It can fluctuate. So that's why it varies. It has a variable. When I say sub, it's just down below. So this little 1, it's, you know, we have superscript like an exponent. Subscript is just down below a little bit. It's just a little number as a label. So a sub 1 is my first term. A sub n is like my last term. And then d is the common difference. So here's the formula we're going to use. What's nice about a formula, you can use it several different ways. So a sub 1, it's telling you again, is the first term. N is the number of terms, and d is your common difference. And actually, if we wanted to, we can say a sub n is the nth term or the last term, usually what you're asking for. So if I'm asking for the 100th term, we're assuming that there's 100 terms, so this is the last one. Right now it's set up to find that last term, but you could plug in any of those values and find anything within those 4 values. So maybe we want to find a sub n. We plug in a sub 1, n, and d and solve. Maybe we have the last term, but we want to find the first term. So we plug in the last term, the number of terms, and d and solve. So there's 4 different things going on there. As long as you have the other 3 variables, you can solve for any of them. Maybe you know where the term starts. Maybe you know that there are 20 terms and it stops at 54. And we know that there's 20 terms in the sequence. You could tell me the d value. We don't know what we're counting by, so d would be unknown. But if we knew the beginning, the end, and how many, we could find the d value. So we're going to use this formula over and over again. So let's go ahead and part A for number 4 is write the equation of the arithmetic sequence. So when we come up with an equation, we can use it over and over again. If you look at part B and part C, we're going to use this equation to find the 12th term. We're going to use that same equation to find the 100th term. So it's an equation that we can work with over and over and over again. So we don't know the nth term, so we're going to leave n as just n. A sub 1 is my 1 value, so my first term is 1. I notice that my difference between these numbers is positive 9. They're increasing by 9 each time, so my d value is 9. So if I use my formula, a sub n is equal to a sub 1 plus n minus 1 times d. I have the a sub 1 value. I have my d value. I'm just missing the last term and the number of terms because I really haven't said what I want the last term to be. So I'm going to get this formula all set up. A sub n is equal to 1 plus n minus 1 times 9. And then I'm just going to clean it up. I won't be able to get an answer, but I can clean this up. I'm going to distribute the 9 through. So a sub n is equal to 1 plus 9n minus 9. The last thing I can do to clean this up is I have a positive 1 in front, I have a negative 9 in back, I can make that negative 8. So a sub n is equal to 9n minus 8. So there's my formula. It says write an equation or a formula for that sequence. Now that I have a formula, I can find any term I want by plugging in the n value. So part B is asking, find the 12th term. So that means n is equal to 12. So if I use my formula, a sub 12, my 12th term, will equal 9 times 12 minus 8. My 12th term will equal 108 minus 8. And my 12th term then is 100. Notice the work I showed. I plugged in the 12, I used my formula, and I plugged in my n value. I multiplied my n value by 9, then I subtracted by 8. I should see those 3 steps in that progression. So if I continue to add 9 to 1, 99 more times, to get, or I'm sorry, 11 more times, not 100. 11 more times, that would be the 12th term. I should be at 100 by the time I got there. If you want to check, we could use our calculator and just keep track on your calculator. The 12th number should be 100. Part C is asking us to find the 100th term. So when we go to find the 100th term, n then equals 100. I don't have to start all over. I have a function. I have an equation to plug it into. So a sub 100, I'm going to find my 100th term, is equal to 9 times 100 minus 8. The 100th term is equal to 900 minus 8. And the 100th term, when you take 8 away from 900, you get 892. Now, if you want to, you could check your answer by using the calculator over and over again, but I think you might lose count after doing it 100 times. This last part rearranges some things. So this last part is where you can use this formula in a different way. Which term of the sequence is 172? So they're giving us the a sub n value. We just don't know what n equals. We don't know the n value. They're asking which term. So if I use that same formula, I'm just going to write down the formula the correct way. A sub n is equal to 9n minus 8. I have 172. I have the actual term. I just don't know what term it is. So by using inverse operations, and I can add 8 to both sides, I'll get 180 is equal to 9n. Divide by 9, divide by 9. This term is the 20th term of the sequence. 172 is the 20th term of that sequence. Now, arithmetic sequences are linear. When you have your d value ends up representing your slope. It's a constant rate of change. So the arithmetic sequence 12, 23, 34, and 45 represents the total number in ounces that a bag weighs after each additional newspaper is added. So write a function representing the sequence. So we're talking about newspapers and we're talking about weight. So it's an additional, the weight of the newspapers. So write a function to represent the sequence. So we have 12 is how much it weighs, and then 23, 34, and 45. So the difference between 12 and 23 is 11, 11, and 11. So that tells me that each newspaper is 11 ounces. So my common difference is 11. My a sub 1 is 12. Now that I have those two terms, that's all we need, we can write a function. So a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is equal to 12 plus n minus 1 times 11. So a sub n is equal to 12 plus, distribute, 11n minus 11. And then I combine my two terms here. A sub n is equal to 11n plus 1. Graph the function and determine the domain. How much will the bag weigh after 10 newspapers are added? So after one newspaper we're at 12. I'm going to count by newspapers here on the bottom. And on the top, I'm actually going to count by 2s. Actually, I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So after one newspaper, we're at 12 ounces. After two newspapers, we're at 23 ounces. After 3, we are at 34 ounces, which would be right above here. And then I can't fit the other one, the 45, but that's okay. You can see that my points are lining up in a line Okay? And the domain are all my newspapers. So my domain is positive integers, because you can't have a half a newspaper, and you can't have negative newspapers. So domain is your x values. How much will the bag weigh after 10 newspapers are added? So a sub 10 is equal to, if I look at my function, 11n, so 11 times 10 plus 1. A sub 10 is equal to 110 plus 1. A sub 10 is equal to 111 ounces. After 10 newspapers, it'll weigh 111 ounces. So the lesson summary, I want you to determine if that first one is an arithmetic sequence. If so, find the next 3 terms. If not, explain why. You can just show me why it's not. And then I want you to find the 25th term of the following sequence using the a sub n formula. Good luck.